Hello students, I'm here to go over volume and surface area, which is benchmark G.7.5. Right now I'm going to be going over the notes, so please follow along. The surface area describes the sum of the areas of the faces of a 3D figure. An analogy would be the skin on a bear. Have you guys ever seen a bearskin rug? That's what I'm referring to. It's the outside or the material that makes up a three-dimensional figure. This will make more sense as we go along and we compare it to volume. What's important for us to know is not only what surface area is, but also how we find the surface area. There's going to be two options. You're going to either use a formula from the reference sheet, and I shouldn't say use a formula, you're going to use the appropriate formula on the reference sheet for the figure that you are finding the surface area of, or should your figure not be on the reference sheet, you're going to find the area of each face and then find the sum, which also means just add them up, add up the areas. Okay, so I'm going to do my best here to draw out what I'm referring to. So here I'm going to draw a three-dimensional figure. Bear with me. And when I refer to surface area, I'm referring to the outside. So that would be this face, which is the forward-facing face. And of course, on this type of figure, a rectangular prism, we're going to have two parallel faces. So there's also the back face. And then we have the side, I should say sides, left and right, and then the top and bottom. So in order to find the surface area, I would have to add up the area of the front face and back face, and then find the area of the side faces, add those, and then the top and bottom faces. That would constitute the surface area. If this were a cardboard box, then we would be referring to the cardboard and not the space inside of the cardboard box, which we'll talk about shortly. There is a unique concept called lateral area. Lateral area describes the sum of the areas of the faces of a 3D figure, which sounds a lot like the definition of surface area, but you're subtracting away the bases. So again, you're going to find the area of the faces, but you're not concerned with the area of the bases when you add them all up. Okay, the concept of base is an ever-changing concept depending on what you're doing, but for this particular figure, the bases are going to be two congruent parallel faces. In the case of this solid, there's there's the front and back, which is one pair, the top and bottom, which is another pair, and then the side to side. So there's actually three pairs here that we could use as bases, but it's not always, you don't always have as many options in other figures, and you'll see that when we get to some of the example problems. Oh, and let me say a little more about the bases. In terms of the bases, the height of the figure is always drawn perpendicularly to the base, but again, that'll make more sense as we go along. Okay, now we're going to go ahead and describe volume. Volume describes the number, that's what the symbol means, the number of cubes that you can fill a 3D figure with. Okay, so we're still talking about a 3D figure, but now instead of talking about the cardboard on the outside or the skin of the bear, we're instead talking about the guts, the insides, the space inside. Okay, I know that's kind of gross, but it's an analogy that you'll remember. Okay, so moving forward, we want to know, how do you find this? So you find the volume by referencing a formula, the appropriate formula on the reference sheet. Okay, an example. Again, I'm going to attempt to draw this. Drawing a 3D figure, a rectangular prism, to be precise. And I'm not going to draw all of them. I'm just going to draw a few. So here I have some squares. And it's important that you note that they are cubes. The cubes can be small cubes or big cubes. But the key thing is that all the cubes are exactly the same size. Okay? I'm going to go ahead and draw this part. Right now they're just squares. I need to make them three-dimensional. So I'm going to go ahead and add this in here and here, and then draw my lines down. There you go. Okay, and let me just add the top, and that'll be the last one that I add. then across here, across here, across here, and across here. Okay, so if you take a look at this, this is very rudimentary, and there's some stuff that I could add in, but if you take a look here, you'll see that there's a lot of little cubes in here. The number of these little cubes in here describes the volume, or how much can fit inside of your three-dimensional figure, or what are the guts. It describes the guts inside of that three-dimensional figure. Okay. An important note is that if you cannot find a figure on the reference sheet, break it into smaller figures that are on the reference sheet. This goes into composite figures, which we won't cover in depth here, but just because you don't find a figure on the reference sheet doesn't mean that you get to stop doing the problem. It means that you need to go ahead and break it down into smaller pieces that are on the reference sheet. Okay, next we're going to go through a very short compare and contrast. So as it relates to surface area and volume, they both refer to three-dimensional figures. Okay, and I'm sure there's other things that they have in common, but in the interest of time, I'm going to focus on the contrasting. Comparison describes what they have in common, and contrast is what they have differently. So let me go ahead and go through the fact that with your surface area, you're describing the outside covering. With your volume, you're describing the inside space. For surface area, you're describing the cover, whereas with volume, you're describing the fill. And then, keeping this very basic, something that you will note is that the units for surface area are always squared, because you're adding the areas of two-dimensional faces. So when you're adding those up, you still end up with a squared unit. However, with volume, you're multiplying 3 units because it's three-dimensional, so you're going to end up with units that are cubed. Okay, I hope you found that helpful. See you next time.